15 minutes. We're gonna start with a 15-minute presentation by Nicolas Roher from Asantys Systems. He's gonna be explaining his experiences on the field on implementing these technologies. After that, William Duren from Odyssey will give us some insights on new developments of this type of technologies. And after these two presentations, we're gonna have a very exciting panel discussion with quite well-known representative of companies within the decentralized power ecosystem. And that will be moderated by Deepak Mahapatra from RVE. Last but not least, there's going to be some closing remarks from Patrick Cousins, PP from Customer Success at Odyssey. You see here in the agenda, we have reserved 25 minutes of Q&A session after the panel. So you all know these questions that will be answered in the Q&A can already start being written in the Q&A button that you will see in Zoom. And you can start putting these questions right from now if you wish, and we will be trying to answer all these questions during the Q&A. If you want to have some live question during this session, you can also click on the raise hand button, and then we will try to sneak in this question during the session. Okay, so I think we can go ahead with the first presentation. Let me just stop sharing. Okay, so our first presenter is Nicolas Roher from Asantys. He's the CEO and founder of Asantys Systems. Asantys is a system integrator and EPC with more than 12 years of experience in mini-grid design and implementation in Africa. And he will give an introduction of Asantys, and he will explain his experiences on the field on implementing these technologies and what sort of benefits or challenges one might find. So Nicolas, thanks for being here, and you can start whenever you're ready.
Yes, thank you, Joanne. And I'm starting my presentation now. Thank you for having us here at Odyssey. We're quite proud to be one of the presenters in this team, and we know the German Ferntech since many years and started implementing projects together since quite a while. That's why I'm here today to present you a little bit case studies, how it is working with a remote monitoring system, with a sophisticated remote monitoring system. I will give a short introduction of what we're doing, not more than 5 minutes, I promise to be short, and then go quickly into a project that we're currently implementing in Senegal, where you can see how remote monitoring is working already at the construction phase, and what meaning it has for an EPC like we are, and I give you an outlook also what we're developing with these tools at the moment, and also give some maybe points that will be handed over to William later, who's working on this kind of subject. So Asantys is a company founded in 2009, and me personally, I'm working since 18 years now in off-grid business. So we're very experienced working in the off-grid field, and we consider ourselves as a 360-degree service provider. So we work, let's say, in all kind of off-grid projects and offering services which are necessary to successfully implement a solar energy project in the rural area. We're into that business since 2009, and there we did only $70 million more or less in off-grid projects. Last year it was 11 million. And a lot of tons of CO2 saved during these 12 years of Asantys. And as you see, we're focused on projects in Africa. So our main activities are on that continent. And there we work as a purely system integrator. So we serve from the first planning up to the installation. We are not an operator, but we serve to developers and operators. Sometimes as in doing also consultancy, and as we really understand what the clients need, and we're definitely every day in the field in Africa. We have an in-house logistics to make complete projects happen, and then we offer trainings and monitoring and maintenance support during the implementation phase. And that's why we come to the subject, yeah, and why we need remote monitoring, and I would say why we need reliable remote monitoring, because we are in that business, as I told you, since many years, and we're always confronted with projects in really very remote areas, yeah, distributed over large areas, yeah. In the case of Senegal, I'm talking about later, it's a nationwide project, yeah. So we need to get somehow access to what we are constructing and installing. Yeah. Then we are confronted with a fact which is kind of sad and it's proving, but it is a fact. We have lots of the times local service technicians that have not enough technical know-how. We have really good installers, but the systems are getting year by year technically very demanding, and I would say normal technicians can quickly reach a limit. Yeah? And also the local service partners, mainly based in the capital of the countries, they need to know what is happening in the field before they travel out, before they support the local technicians in the field. Yeah? We are interested in having a good remote monitoring because we need to limit the blackouts. Yeah? The systems often work without diesel generators at the moment, and it is really crucial to anticipate system failures or load mismanagement in order to limit the time of the blackout for the operator, for the investor, especially also for the populations. Yeah, we have cases where it could take hours and months before in the past, and today we try to see the failure of the system immediately and try to be within, let's say, 24 hours, sometimes even in hours, to repair a system when it's down. Yeah? And last but not least, we say remote monitoring is very important because the lifetime of the system is depending on the temperature control. The warranties are depending on temperature, and we have to give guarantees to the investors if we hand over a system as an EPC. So, for example, we used a lot of lead acid batteries, and the lifetime of these batteries is a very critical issue. If you calculate the complete system, and the lifetime of the battery depends on the management of the temperature. So these are reasons why we chose Odyssey's or Frontex system in our systems in the project in Senegal and also in other projects. I'm talking here about a very big project of rural electrification happening right now in Senegal, which is conducted by the Senegalese energy agency AZER and the German engineering company GAU. And we are chosen as a partner of them to install a total of 120 plus X containerized power assets in different villages all over Senegal. The implementation started late 2020. So last year, we installed the first almost 50 containers and currently another 50 under construction. And I wanted to ask you a question. Yeah, I chose a picture and asking you, can you understand what is this? What is this picture, and how is it related to remote monitoring talks? I can tell you the answer is quite easy. It looks a little weird or strange, but it's a case which is happening in real life and where the monitoring system, management system was helping us a lot. The reason is we had a containerized system in that it was perfectly running while the commissioning, perfectly. And then suddenly we found a system alarm in our monitoring, and the AC went off without any explanation. Yeah, everything was fine, and we had been there just some weeks before, and was not working anymore. So we had to send a team on site, a verification team, and we found out a new unknown site condition. We have a spider problem in some areas in Senegal, and the spider was making its nest, I don't know how to say in English here, into the evacuation tube of the ACs, and it was completely stopping the AC and even getting some water into the system. So this was quite at the beginning of the system, the spiders living under the solar panels and stopping our system completely. So from then on, we could easily find a solution to prevent spiders from getting into the system at this particular point. But we only found it out because the monitoring was giving us alarms during the construction time. The second story. We try always our best. You have a nice and good system, and we have 5 teams working in parallel installing systems. And in the past, we as Asantys had some experiences of misuse of the temperature sensor in other projects. So I was suspicious when I got a new abnormal temperature warning and was saying, something must be wrong because I have no explanation for it. One of the two battery benches was overheating a little bit, well, like we're talking about 2 degrees, yeah. But the AC was working, so it was no spider, yeah. And only one battery bench affected. So in the end, we found out that one of the battery sensors was wrongly placed, and it was helping us as giving a false measurement of temperatures, which is very bad for the battery management system. And we could immediately introduce corrective instruction to the installation teams, because apparently there was one out of 50 installers who was not placing the battery temperature at the right place. And by mistake, unfortunately, we didn't recognize this during the reception of this container. So we could install, correct it quickly before it was giving damage to the system, and we could have an improvement of our teams, because it's an evolving process. And in that case, we can say the monitoring was helping us to evolve our teams on the ground. Here, I want to just give you a little impression how it is in that field. For the first 45 villages, they're in an area of more than 500 kilometers, yeah. And in the first two systems, we had a lot of time, 1 to 2 days to commission a monitoring system. And then we learned very quickly how to pre-configure it. And today we can, let's say, immediately during the commissioning, see what is happening in the system from here. So we have a double control that our technicians in Germany, in Senegal, and in the field have the same access, and we can discuss if there's any thing that would be abnormal during the commissioning already. Today, we commissioned 4 villages in the south of Senegal remotely with my colleague Jacob. Here you see a little bit how the portal looks like. A typical view in the morning when somebody of us is controlling the systems. You see 35 systems are currently working online. 1, there is a mistake which has to be controlled, and 28 are under construction. That's why they're all offline. 3 of them are in the systems already commissioned, but no connectivity. So to give you an outlook on what Asantys is currently developing in this project, we used a sophisticated remote monitoring system because we have in mind that we have to optimize also the internal loads of our containers. So the next step is going to be connect productive uses when the loads are coming into the project. We need an excess energy management and the load controls into the systems, to integrate somehow the load controls into the system. There are no limits set. So we are preparing ourselves with a already today up-to-date state-of-the-art monitoring system, but ready to connect with the development of the village in terms of load, and also if we have to extend them one day to have the optimized optimum solution. But to give you an example, when I was talking about optimization of internal loads of the container, there's one village called Bode, where I took a graph from my colleague Karama this morning, and to show you an example of a 2-day load curve. The village is a simple small kit for a small village in the ASEA 300 project of a 15 kilowatt PV container. And we tried to optimize our cooling system with the monitoring, and could currently get an extra average of 16.5 kilowatt hours per day just by using this remote monitoring system. I don't want to go too much into details how we did it, but we have customized support from Odyssey to do so. And we put into some intelligence from Asantys using the smart monitor from Odyssey. And today we can offer to the customer 16.5 kilowatts per day extra. That could be used to cover extra households, or as a reserve for the future customers, or even if we want so saving also battery lifetime, because we don't use the energy, which was in a traditional way already calculated in the project. But nevertheless, we also have some unsolved problems and some future topics, and William's going to talk about it later. We come from a situation where remote monitoring was extremely difficult. The amount of data was not possible to get it transferred, even if we had, let's say, monitoring systems from existing brands. It was not working at 100% of like we wanted to have it. So what we found with Odyssey system is a big improvement to what was available in the market so far. For example, during this installation of the first 45 containers, only 3 sites had not been reachable by the telephone communication, where maybe we should have today one day a cheaper, good satellite connectivity. But the data flux was perfect. So it is in progress. It is really good compared to what we know, but it's not 100%. Yeah. So we are happy to contribute to find solutions. We'll see what will happen in the next month. Another system problem is, I'm talking, we are giving customized solution. Customized means also no standard. So at the moment, remote monitoring systems, in my opinion, give also too much work for the customers. It's not a plug and play system. Yeah? It's a complicated monitoring system for engineers, for specialized companies. And maybe one day will be easier also for the end users or to come to good end user levels. Yeah? But we are an EPC, we're not an operator. Yeah? And on an operator level and how technicians in the field will use it, it is kind of, in my opinion, sophisticated what remote monitoring is offering today. But it is under development, and we are in the beginning of a big development. Yeah. So the question for me that is open is how to integrate the system we have right now into a last mile system. But I think I'm pretty confident that we will find solutions, and with the help of Odyssey also integrate this. Maybe the other presenters can talk about their experiences as operators with the system, and you get a different appreciation of what I'm saying. My name is Nicolas. I would be happy to be in touch with you. If you have questions, just drop me an email or contact me on LinkedIn. And I would like to hand over to William from Odyssey, and who's giving you a more technical introduction into the systems. Thank you very much.
Thank you, Nicolas, for the great presentation. If you can just end your, once you end your share screen, then I can, thank you. Just a quick reminder for everybody, there is a Q&A button located in the bottom right. And so you can submit any questions you might have through this Q&A channel, and they will be, we'll try to answer those during the, or the panelists will try to answer those questions. So with that, my presentation today is going to focus on new developments in remote management. It's a real pleasure to be here today and to be presenting alongside many leading industry experts. It's also interesting to be presenting today, as this is about the 2-year, or it's almost exactly the 2-year anniversary of the launch of a report, Energy Access, Data and Digital Solutions from TFE Energy. I was the lead researcher on that project about 3 years ago with funding from the German government and the German Ministry of Finance and Energy. And a big focus of that report was on Odyssey Energy Solutions, which was one of the case studies. So it's great to be working for Odyssey Energy Solutions. And another big focus of that study was on remote management and their role in operating energy access assets. And it's been wonderful to see how much the market has evolved over the last 2 years. And so with that, the first thing that I just want to review is the evolution of remote management technologies for DERs, where DERs are distributed energy resources. Here at Odyssey, we usually classify the remote management technologies into 3 generations. And so what we have in the first generation, this is in the early 2010s, whenever mini grids were first starting to gain momentum, and there were a lot of pilots going on. This segment can largely be classified as a time when solutions that weren't necessarily fit for market were being used just to do proof of concepts. And a really good example here are microgrid controllers that were designed for other markets. So right around this time, whenever the mini grid market was taking off, the microgrid market in North America and Europe was thriving. And so some examples of that were the SPIDERS program in the US, which was microgrid control or microgrids for military bases. But the issue with these microgrid controllers is that they were extremely expensive, costing tens of hundreds of thousands of dollars. They didn't necessarily answer the pain points for mini grids. There were other solutions that were being used. And so in terms of aggregating data or collecting data, there were data loggers such as PLCs or computers being used just to collect that information locally. And oftentimes that data would be visualized on local computers with perhaps an Excel spreadsheet. Moving away after that proof of concept came the first generation 2 microgrid or mini grid remote management technologies, or really technologies for all distributed energy resources. And these were fit for market controllers. So it meant that they fit or hit the pain points, but they still came within a price range that actually worked for the market. Oftentimes these are paired with cloud-based analytic platforms. And so this had a huge benefit that the data could all be uploaded into a single platform instead of being viewed individually at different sites. And it also meant that that data could be viewed anywhere in the world with an internet connection, meaning that network operating centers could be established. Another big part of Generation 2 remote management technologies was how action was performed. And typically these were actionable insights that then required human intervention. And so a good example of that is, perhaps an operator sees that the SOC is approaching 20%, and so they manually go to their generator and they switch over to manual operation on that generator. And whenever we looked at Generation 3, that's what we consider what is happening now. And so that doesn't necessarily mean what we see happening in the next few years. These are things that are actually being used in pilots and commercial projects today. And so in terms of aggregation, what we're seeing and what is being developed is system-wide monitoring. And part of this is as mini grid portfolios are approaching several dozen, if not hundreds of systems, they just need system-wide monitoring where all the systems can be viewed in a single platform. Similarly, they require automated reports that allow them to assess how they're performing over their entire fleet. Additionally, these automated reports are important because they help inform the market and ideally de-risk investment into the market. And finally, there are control algorithms which are actually designed for mini grids and for the DER market. And we'll get into more detail here shortly into exactly what that means. And so first, just touching on some of those current advancements in terms of aggregation. One of the most important things is universal compatibility. And that's something that is finally, or is really becoming possible. And universal compatibility and sensors kind of go together. On one hand, whenever we think of universal compatibility, as a mini grid operator has more and more sites, what they realize is there might be on one system, you might have Victron inverters, you might have SMA inverters, you might have Huawei inverters on a different site. And so the ability to bring all of those different data points into a single portal is extremely important, or into a single web platform. And additionally, being able to bring in sensors that aren't necessarily part of the power system is very important. And what we're seeing is a big shift towards being able to have non-power system data. So for instance, if you have water pumping on your system, it'll probably be very important to have a water flow meter and have visibility into how your water pump is performing. The next 2 points also go together to some extent. And so we have system connectivity and we have data compression. In terms of system connectivity, this is, Nicolas actually did a really good job priming that. What we see is 2 trends. And so the first trend is the need for smaller amounts of data. And so just the ability to move from having more than 1 gigabyte of data per month being consumed, as those data fees cut into the bottom line of the mini grid operator. But additionally, if you are in an area where there's weak connectivity, you might not be able to transmit all that data on a 2G or 3G connection. So one shift we're seeing in terms of that weak connection is having satellite communications. So interestingly, nearly 4 years ago, whenever I did a study for the European Space Agency, the study was focused on the use of satellite technology for mini grids. And in that case, or at that point 4 years ago, satellite communication was just too expensive. But what we're seeing is increasingly mini grid operators are finding that the economics are starting to work for satellite communications for some systems, and we're seeing it deployed more often. The next section where we're seeing a lot of, or where there's a lot of advancements are on analysis, and the main areas there are in terms of metrics around major components. And so between your PV system, your batteries, and your diesel generation, you have a large portion of your CapEx, as well as your operational expenditures, your ongoing expenditures. And so it's really important being able to assess the performance of those. And having this analysis is feeding into the ability for to be able to react. Specifically, this action should be automated, so there should be no need for human intervention. And we have 4 examples here. One of the easiest examples to picture is optimizing diesel consumption. So diesel oftentimes is a large operational expenditure. And so any ability to optimize how much diesel is being consumed here for mini grid operators is extremely important. And we'll go into some real life examples on the next slide. Another important point here is supporting productive use equipment. And so productive use equipment has been in discussion for as long as I've been in the energy access industry. But what we're seeing is there's a real trend, or there's real traction around productive use equipment. But making that business case and making sure that this equipment is able to be maintained, it's extremely important that there can be automated action around it to optimize its use case. And so, as I mentioned, these Gen 3 developments, that they're not, we're not projecting them coming in the next 3 or 4 years. These are things that are happening today. And so we have 3 examples here from Nayo Tropical Technology, and Anayo will be speaking today. So definitely looking forward to that. Equatorial Power and GIZ. And so in terms of Nayo Tropical Technology, they were able to use a remote management technology to manage a large fleet of very different components and bring all of that into a single portal. And that's by having all that data in a single place, they can now analyze and act upon that data. Another example is Equatorial Power. And so many of you might have heard in the last couple of days that Lowway has been commissioned, which is a joint project between Engie and Equatorial Power. And they're a really groundbreaking project in that they've combined both generation and load. And by monitoring both of these systems, they're able to analyze and ideally in the future, continue to optimize the way their productive use of energy is used. And finally, the example we have here is a project we've been working on for 2 years with GIZ. And this project is a bit of an extreme example, but it really highlights the ability that you can have with diesel genset optimization. And so here we've been working with GIZ, and we're forecasting that the system will be able to optimize approximately 40% of its diesel consumption. And this is hardly the only project that we're working with around diesel optimization. In addition to this, we've been working in Chile for over 3 years with a number of systems where we've been optimizing their diesel genset consumption. So if you're a mini grid operator, don't think that being able to implement any control algorithms or optimize your diesel genset is something of the future. You can definitely do it now. So with that, I'd like to thank everybody, and I'll be handing over to Joanne to introduce the panelists.
Thanks, William. Thanks, Nicolas, for these very interesting presentations. And now is the time for the panel discussion with the rest of our panelists. The panel will be introduced and moderated by Deepak Mahapatra. Deepak is the Policy and Business Development Officer at ARE, the Alliance for Rural Electrification, which is a global business federation representing the decentralized renewable energy sector for provision of energy access in emerging countries. Deepak works closely with ARE members as well as with international and local partners to improve policy and business development conditions for private sector companies in decentralized renewable energy markets all around the globe. So thanks, Deepak, for moderating this panel, and I'll leave it to you to kick this off.
Thank you. Thank you so much, Joan, for inviting me to this very important and very informative panel. Ladies and gentlemen, good morning, good evening, and good afternoon to you based on your time zone. My name is Deepak Mahapatra. I'm working as the Policy and Business Development Officer at the Alliance for Rural Electrification. So as Joan was mentioning, ARE is the International Business Association mandated to promote a sustainable decentralized renewable energy industry for 21st century by activating markets for affordable energy services, creating local income, inclusive economies, jobs, and so on. So to just touch upon the topic of the day, I would like to give you some facts and figures. Globally, the number of people without access to electricity has declined from 1.2 billion in 2010 to 759 million in 2019. Electrification through decentralized renewable-based solutions in particular gained momentum. The number of people connected to mini-grids has more than doubled between 2010 and 2019, growing from 5 to 11 million people around the world. Now, building on that, remote management has been a key, let's say, a key role player in this particular segment, what we are talking about in the distributed energy system. And just to talk about that, I have the pleasure to invite our intellectuals who have agreed to share their insights, their experiences with you. Before introducing the panel, I would like to reiterate this fact that, dear audience, kindly note that this webinar is being recorded, and the recording as well as the PowerPoints will be made available to you by Team Odyssey. Kindly also make sure to use the Q&A function to ask your question, and please name the speaker or panelist that you are addressing this question to. Therefore, without further ado, I have the pleasure to invite our panelists today to this power-packed panel. And it's an absolute honor to share the stage with the existing president of ARE, Mr. Claudio Pedretti, who is also the CEO of Green Climate Ventures, the former president of ARE, Mr. Vivian Vendeirinho, representing RVE.SOL today, then our member Asantys, represented by Mr. Nicolas Roher, and Mr. Nayo Okenwa, who is the CEO of Nayo Tropical Technology. Dear panelists, may I invite you to kindly turn your camera on and unmute yourself, and we will shoot with our first question. And that's your cue. And let's start with, before going into the questions, let me invite each of you to introduce yourself briefly and also talk about your organization or your company, so that our speakers, so that our audience will get to know who we have on this auspicious panel today. So let's start with Mr. Vivian Vendeirinho, founder and CEO of RVE.SOL. Vivian, the floor is all yours, and you've got a minute to introduce yourself.
Thanks, Deepak. Good afternoon, everybody. My name is Vivian Vendeirinho. I'm founder CEO of RVE.SOL and Kudura Power East Africa. We currently employ around 60 people in Kenya. Been developing projects there for the last 9 years. We commissioned our first project 10 years ago. We currently serve around 4,500 consumers, all decentralized mini grids, typically in the range of 15 to 70 kilowatt peak. And we're currently developing projects in Mozambique and Madagascar, and keen to understand better what opportunities exist in West Africa. Thank you.
Thank you. That was a brief introduction, Vivian. Let's move over to Mr. Claudio Pedretti.
Thanks, Deepak. Hello, everyone. Thank you very much for the invitation. It's a pleasure to be here. My name is Claudio Pedretti, and I am the CEO of Green Climate Ventures. We are an impact investment firm, so we make a direct investment in startup operating in the access to energy space, and we have a particular focus on companies that are working in productive use. At the same time, we provide help to developers that needs to finance their pipeline of projects but most of you probably know me for my past experience in other company, especially in system integrator. So that's why I'm very happy to be here discussing about remote monitoring, which is a topic, Deepak, as you mentioned, that is crucial to allow distributed renewable energy to reach the goal that have. Thank you.
Thank you, Claudio. Let's hear it from Mr. Nicolas Roher, please.
Well, I had just a presentation of myself. My name is Nicolas, and working as a managing director, one of the managing directors of Asantys Systems. And as I said, we have the pleasure to be one of the partners and working in Africa since 18 years and having implemented, I don't know how many the systems on our counter. It is 7,600 systems African-wide. So that's our experience that we bring in here.
Thank you, Nicolas. Last but not the least, may I have on the stage Mr. Anayo from Nayo Tropical Technology, please.
Yeah, hello everyone. My name is Okenwa Anayo. I'm the CEO and co-founder of Nayo Tropical Technologies Limited. We're based in Abuja, Nigeria, and we have operating mini grids spread across Nigeria. Our company was founded in 2004, and we've grown to about 56 direct staffs and well over 30 contract staffs. We currently operate 10 mini grids in Nigeria with over 9,600 customers, and we're scaling at the moment. We have a pipeline of over 62 mini grids built for commissioning in the next 24 months. We're also looking beyond Nigeria. We're looking, across the, the West African sub-region. We're happy to be here on today's event. Yeah, thank you.
Thank you, thank you, audience. So please take note. Here are your panelists for the day. Let's start with the questions. So, well, my aim would be to keep this discussion as interactive as possible. Therefore, we would go with one question and then take opinions from all so that we can see how every one of the panelists are contributing to the cause and contributing to the decentralized renewable energy sector as a whole by bringing in their insights to for remote monitoring and remote management. So we saw the presentation by William, and there we saw how important is the data collection and management is for that. Let me start with Vivian. The question would be, how important do you think data is for scaling up distributed power systems?
Sorry. I think it's absolutely imperative. I think our business starts, with a huge assumption, which is assuming what people are going to consume in energy when they've never consumed energy before. And right now across the sector, we're all making assumptions that are, varied and different based on our experience. And very often, I think for many of the operators, that's not based on real hard data and being able to build demand profile curves over time based on type of customer. And so I think certainly from that perspective, being able to match that with what a system is expected to deliver, and almost most critically, particularly in a business that is very CapEx intensive, and where there are a lot of unknown variables at this point, is being able to estimate very well what you expect the demand is going to be like in the first 2 or 3 years, deploy the most efficient capital that you can in that period, and then plan on upgrading over time, as opposed to what often happens is overextending yourself in the initial deployment, and then realizing that you have excess capacity that you need to figure out how to use.
Right. Indeed, yes. We need to rather focus on the real-time data rather than being, let's say, too much into assumption-based while designing or defining a system that is focusing on a consumer base which doesn't or which don't have any experience in the power or with the modern forms of energy services. Moving on to Claudio. Moving on to Claudio, I would also ask the same question to you, Claudio. How important do you think data is for scaling up distributed power systems? Claudio, may I ask you to unmute yourself, please? These are the perks of doing webinars.
Yeah, thanks, Deepak. No, I wish to echo also Vivian for what he mentioned. And there was a time which is apparently now over where the load of a mini grid was very well predicted, right? Or it was believed that it was possible to predict it before. And the dimension of a solar plant for a mini grid was decided before, and also consequently the investment. Then the profitability of the project was a separated topic, right? But now it seems that that time is over, and as Vivian mentioned, and he probably now is actually acting in that way already is possible thanks to some technological innovation to very well increase the capacity of a solar plant, to scale it up relatively easy. And this can be based on real data that we can acquire in real time thanks to the technology we are talking here today, remote monitoring. And based on that data, you can scale and make investment in a very conscious manner. Also, remote monitoring is acquiring, in my opinion, a very great important from whoever is financing the mini grid, especially private impact investment company. They are increasing interest in those technologies, because this is the only way that they have somehow to do some asset management, to have at least some guarantees that their assets that they are financing are treated well and they are working well. And at the same time, data monitoring, it's a useful instrument to define impact measurement, which for some investor it's very important. And of course, there are a lot of advantage when we talk about operation of the plant, as also Nicolas mentioned it before. I cannot imagine about running an off-grid system in those remote areas without those technologies.
Thank you, Claudio. I think the key point that I would take from your intervention here would be the investor confidence. So if I see it well, with the success that is brought to us by the remote management of this off-grid system, that has bring forward, or let's say that has increased the confidence of the impact investors, or from the both public and private sector, that yes, my money is not going to be wasted if I invest in these projects. It's going to come back. And with more investment from the private sector, with more success from the technological advancement and the mini-grid developers put together, we can have a better and more reliable power system. And the more, let's say, prosperous these businesses are, end of the day, the consumers are going to be happy with the energy, with the access to energy that they get, which they didn't have before. I think that's a very important point that you mentioned, Claudio, right there. So moving on to then Mr. Anayo, I would like to also take your 2 cents on this point of how important do you think data is for scaling up distributed power systems?
Yeah, thank you, Deepak. Data today, is everything. As everyone, as technology keep evolving, livelihoods, private homes, everybody wants to have access to their businesses remotely. Without you can imagine an investor putting money, just like Claudio said, and assume to be getting paper reports. Rather, can't compare that with having direct access, from an IoT setup, a kind of a remote monitoring system. And it can be more important. And now a lot of private investment is moving into this space. It's a new industry that has not built confidence over a long time. So investors are very, very worry about quality of data they are getting out from these assets. So one is in quality and integrity of the data. If investors have direct access to this equipment and they get improves that confidence in the profitability or performance of these assets. Thirdly, it goes beyond just funding and setting up these systems. It's also very important during the O&M part of the project. Increasingly, access to sites for any typical operator like us has always been a challenge. Remote locations, security, logistic costs, and all that. With remote management tools like this, you could at a finger, at your fingertip, pull up information, call a local technician. You don't need to place expensive field men on the ground. You could have a junior technician on ground, and with support, remote support, you could solve very complex problems without spending so much money. Mini-grid has very small, profit margin, so you have to keep it lean. So IoT helps us keep operations as lean as it can get.
Thank you, Nayo. I think building on Claudio's point, you also mentioned how quality and integrity of data drives the profitability and longevity of the assets that we are talking about here, because without the knowledge of how the power systems are going to operate, we are not going to have the confidence of the investor, just building on the previous point. And without that, we will not have the money to build the project in the first place. So I think this is a very important point. And I think to second the point on the security, yes, remote management has done a lot to, let's say, to make the project developers feel more secure about their systems, that, okay, with a very minimum local, let's say, human intervention, many things can be managed online, or many things can be managed remotely that might save the cost of human resource, as well as, of course, the cost of flying. And then there are other interlinked costs of flying, which then turns to pollution and the carbon emissions and so on and so forth. This list goes on. Thanks for that. Let me also go to the last panelist for the same question. Nicolas, may I have also your inputs on this question on importance of data?
Yeah, thanks, Deepak. I thought I was already raising my hand. Yeah, so many good things had been said to this. And in the beginning of my presentation, I was when I was giving the overview about why we need remote monitoring, it immediately came to mind. I mean, data in general is money. Yeah, however you treat it. Yeah, it can be in a bad way, like in social media, and you just sell the data. Yeah, or the data you get from your system serve you to optimize. And I wanted just to point out one of the things that had not been said correctly, but security for the assets. Yeah, what you said for the investor. I mean, I have the experience of 18 years in business, and from time to time, customers come back and say, "See, this battery was crap. Yeah, you sold me a battery, and after 4 or 5 years, it's not working anymore." Yeah, and I said, "Yes, but you stretched the battery maybe too much." Yeah, and in the end, if you have no proof what happened to your battery because it's just not working anymore, you will never have a warranty case, or for your inverter or whatever it is. But for example, a battery is maybe 40% of the hardware investment, and so we have a very close view on the temperature of the battery, and we can prove to our supplier that maybe the battery was never exceeding such and such temperature, and it was cycled that many times. And so we have a deep view into the system, and it didn't happen so far, but if it will happen in the future, we can analyze it and then give this warranty case to the customer. Or let's say if it's a warranty, it's a warranty, and then you have a replacement. But it's very interesting, and their data is pure money. Yeah.
Nice. I mean, it's so interesting to hear that different puzzles, different pieces of the puzzle coming together. Now we have also this piece where we talk about the operation and management by the end users themselves, how they use, what are the ways, if they're, let's say, mismanaging the system or not following the instructions given by the project developer to them, So this is quite important that sometimes the data can also be wrong in sort of a way, which might lead to the breakdown of the system. So I think, of course, this is a very valid point and very important one. And with this, the first question, I think we have in a nutshell found out how data can be a significant player while defining or designing the power system, the off-grid power system, as well as in the operation and management for it, so that we can ensure ensure the longevity of the system altogether. Let's go to the second question of the day, and I will start over with Vivian here. I'm sorry, Vivian, you have raised your hand. You have a point there, please.
Yeah, I did. I just wanted to extend a little bit on what Nicolas said. You know, if we consider where the sector was 10 years ago, you know, a series of individual projects, experimental, where we are now, where investors are starting to look at mini grids as, you know, investable asset class. We're also fast moving to a scenario where investors are investing into asset companies that own the assets, and an operating company is managing the asset on the ground. And speaking a little bit more to Nicolas' point on money, when an asset company is paying an operator for a particular service, in terms of operations and maintenance, access to data at the asset level is fundamental to being able to prove if in fact the operator is doing what they're contracted to do. Whether that is, you know, battery maintenance, or whether that is, you know, panel cleaning, the most simplest level, whatever it is, it's kind of important that you have visibility on the different parties within the context of owning as well as operating the asset, because that then ensures that the assets, the investor at the end of the day, the asset company, is getting value for money in terms of operating the asset. Thank you.
So
may I add just one story? Vivian told a perfect example. It just reminded me, cleaning the panel. Yeah, we had a case, very funny case, where installer went out 5 times because in the telecom system, yeah, and every time he comes to the site is perfect. Yeah, if he's in the capital, he was called, it's not working. Yeah, and in the end, let's say one day he found out that some guy, the wife of the guard of the system, was putting his washed clothes on the panels. Yeah, and they didn't know because there was no monitoring. Yeah, and we could have found out very quickly, very easy from remote. Hey, at a certain hour something is happening on the panel, but we didn't know. There was no real monitoring available. That's 15 years back. Yeah, but that's a funny story where I would say running out 5 times, 3 hours car ride somewhere in bumpy roads in Africa. That's a nightmare, and that's a huge progress. Yeah.
Can imagine, definitely. I mean, with remote monitoring, we would know the exact hours when we are facing these problems, and then we could have rectified, or let's say identified the problem first, when we even without going those kilometers riding. And also, to building on the point of Vivian, I think clear allocation of roles and perfect mentioning of what are the instructions which are forged by the 2 parties here in this case would be that would be the contract between the project developer and let's say even the investor. That can also be a very important lesson learned, and thanks for sharing that experience with us today. Okay, moving on to the second question. So then, since I was talking to Vivian, you have the mic here. How do you think developers manage their assets before we started using the remote monitoring? Please share some insights based on your experience. I remember before during the intro session, you were pointing at your white hair, which means a lot of experience in this field. So may I have pick out some experience from there, please?
Yeah, I mean, it's a great question. We're currently facing a bit of a challenge in that sense. So we have, as I said, 4,500 customers, around 300 kilowatts of peak in deployed assets. We started with one technology, SMA at the time, because it was simple and clean and robust, albeit at a price premium. As we started to scale up, we were able then to raise funding to expand, and we were under pressure to keep costs down. So we stepped away from SMA and deployed a Korean technology. So we now already have 2 different types of technology. And then with the acquisition of some sites from Vulcan 2.5 years ago, we have a 3rd type of technology. And in fact, William has been working with us extensively to try and come up with a solution that will ultimately give us exactly what what I think Anayo mentioned, and this is ability to be able to monitor these assets across one platform and have visibility on them all. I think, looking at the sector right now, the sector ranges from, a number of smaller players that have 1 or 2 sites, been able to fund it one way or another and are looking to grow. And then there's a number of players that are, at the 5,000 connection level, and a few more that are hitting 10,000. And I think when you get to kind of 5 to 10,000, you start to realize that you cannot scale the model linearly. Just because you put in a new site doesn't mean you need a new technician, and you need to figure out how to achieve economies of scale in order to be able to keep your OPEX per customer low enough to be able to make the small margin that Anayo was talking about. And so I think, as a sector, we're going through a bit of a change right now. A number of the companies are starting to grow up, getting some serious investors on board that have requirements that traditionally come from a large scale grid type of asset base, and they're like, yeah, there's no reason we shouldn't be doing the same thing. It gives us the visibility we need. And so most of us are kind of grappling with these challenges right now. It's standardizing on technology, at least from a monitoring perspective, and then being able to consolidate data. I hope I answered your question.
Yeah, I think that's a very valid point. I mean, how different experience based on a grid-tied power systems, then driving on to off-grid power systems. I think that's a very nice transition, and we learn from different experiences based on the projects in different areas. You mentioned about Balkans, and we talked about Africa and other continents as well. Same question, moving on to Claudio. Claudio, how do you think developers manage their assets before we started using remote monitoring?
Well, thanks for the question, Deepak. And I can mention my own experience.
Please, yeah, that's the objective of this webinar today.
Yes, my own experience, and it's partially also one of my passion, right? Data acquisition. Several years ago, I was working on a project, on an off-grid project for an industrial application for the systems that we have put together. They were powering off-grid telecom towers in Central Asia. In an offshore platform in the Caspian Sea. So very challenging condition. We had wind turbines, solar panels, lithium iron phosphate batteries. So you couldn't think about running such a system when your contract was bound to reliability and uptime. You couldn't think about running it without monitoring system. But at that time, there was not that many nice companies like Ferntech or Odyssey offering this off-the-shelf product. So basically, we had to set up that by ourselves, and it was quite difficult. It was very interesting and fun, but we had to set up a system by ourselves, and it was a big fight. A lot of time and money went into that exercise, because you can find off the shelf many data acquisition hardware. The point is having the many information that you can acquire relatively easy working for you. So you need to extract the information that you need, and nowadays, it's obviously much more easier thanks to technology that are integrating part of the knowledge that the operator have into some simplified system like Ferntech ones and the other that are out there. And if I'm thinking about the future, the hope is that we see much more knowledge integrated into those simplified systems, because one thing is acquiring a lot of data, which is now quite relatively easy to do. Let's say you can acquire all kind of values that you want from a plant. The point is integrated the knowledge that allows you to interpret that data. So the knowledge needs to go into algorithm that tells you what to do, because thresholds are not enough. It's not enough to measure. Well, in some cases, it's enough if you see the temperature of the batteries that goes over 45 degrees and you have lithium batteries, definitely you have to do something immediately. But you can do much more before. For example, if you monitor, I don't know, the internal resistance of the lithium iron phosphate cell, and you see trends in the internal resistance, then you can tell a lot way in advance before shall fail and before a problem arrives. So that's where we want to see this sector goes. We want to see those systems predict the problems before they become a tangible and costly issue. But we are going there thanks to the scale of the sector and all the experience that all the gentlemen here can bring to the table.
Yeah, I think you raised a very important point, Claudio, here. Automation based on real-time learning, which is something that we couldn't have even imagined 15 years ago or so, which I think now the off-grid sector has come a long way with the advent of more and more technologies, and with companies and key players like Odyssey, Frontech, bringing up more and more innovative solutions to the table, and bringing up more and more ways how we can manage the systems which are installed in a remote area, in a remote continent, without even going there. The same question to then Mr. Anayo. Anayo, what do you think? How do you think the developers manage their assets before we started using the remote monitoring? If you can tell us or share with us some real life anecdotes, that would be awesome.
Yeah, listening to Vivian and Claudia, I couldn't help, going back to the early days when we were building small systems. You might call them nanogrids then, for remote hospitals in Ghana, Nigeria, and Tanzania. I happen to have, worked with Negiba Cologne, a German firm, an EPC firm in the late 90s, between 1999 and 2001. And during those days, we had a lot of these projects, and we keep having it. You can imagine I'm based in Nigeria, flying to Ghana or Tanzania to troubleshoot remote hospitals. When you land at the airport, you still have maybe a whole day drive into the hinterland to get to the hospitals.
Right.
So I recall we had to set up a brute automation system, whereby we have sensors that use other battery sensors to shut down. We had to prioritize critical loads and non-critical loads. But this created a lot of issues, social issues, disconnecting people and doing that. But today we could do that remotely, and either by using data we've collected over a period of time to set up complex, sophisticated kind of algorithms to switch on these systems automatically without even you sending the command. So these things, this is just the difference. I don't need to fly 2,000 miles to go and switch on, or to make such interventions. Now, speaking of that, today's remote monitoring technology goes beyond just, like Claudio said, collecting data, seeing what do you do, how do you intervene when you have such issues, both on the technical side and also from the business point of view. We have a situation where you have excess energy and you have customers, and you don't know what to do with this excess energy, and you're sitting on the dashboard looking at this energy. Today we could align data collected from remote monitoring to our business development activities, whereby we could analyze this over a period of time, draft a business package, move out the approach customers, productive use customers, and say, hey, we have this excess energy. We've been able to integrate our metering technology and our powerhouse equipment on the same portal on the Odyssey platform. So with this kind of capability, we could monitor technical losses and financial losses real time. And what you have in between is profit. So we're able to design or create business opportunities out of those data we've collected over a period of time. We can approach a productive user and say, hey, we notice that we have excess power within 11 p.m. and 3 p.m., 11 a.m. to 3 p.m. on Mondays to Wednesday, but it's not the same on Thursdays, because on Thursdays, there's a village market that consumes this power. So we're becoming more precise, not just set it at that. So because the system are more intelligent now, so they could always adjust. If there's a festive day in between or public holiday, the system could, quickly react accordingly. So those chip-offs here and there is where the profit lies in mini grids. So these are the future of remote monitoring, acting automation, using this data real time. In fact, we're also experimenting right now on using remote customer service platforms to reach out to customers to do kind of power auction, where you have customers, you could reach out to them and say, hey, we have cheap power, we could sell maybe 40 or 50% at XYZ time. Customers can book into it. We could set up our system to deploy this power to those productive users at those certain times. This is undreamt of maybe 2 or 3 years ago. But with remote monitoring capability, you could auction power real time to customers, and the system, if things change, the system will automatically adjust accordingly without human intervention. So there are a whole lot of capabilities, not in the future, it's happening right now. We're test running some of these technologies I just mentioned now. So, but a few years back, this kind of capability is just a mere dream for a mini grid operator. So there are a whole host of opportunities. We have mini grids where if you find out a mini grid is not productive, you could decide to go into water. If you find out the community needs more water, you drill water, pump water, and sell. Adds an extra stream of income to the mini grid to make it viable. So there are a host of possibilities. By the time you start processing data and you understand what to do with data, it can improve the viability and sustainability of the project on the long run.
Right. I think precision is the key, and it's funny and yet true that we had to take like long haul flights just to connect 2 wires which were broken before. I mean, now with the technology, we can identify it, track it, and then do it with very minimum human intervention that we have. And one thing that I really liked about your intervention, about your statement here, is the allocation of excess power generated to the productive use consumers when they need. And this allocation can be effectively done with the proper data collection and management, so that every consumer can time their needs and can time their, let's say, requirement based on the time of the day, based on the day of the week, and based on the month of the year as well, if we extrapolate the figures here. I think that's a very important point, and our audience can take note of this, and including all the project developers, that this is a very great idea, that if you have excess power, then let's not let it go waste, rather use it effectively so that productive use end user can take that excess power, and then it is, let's say, effectively used, so to speak. Moving on to the last, but not the least, panelist, Nicolas, your view on the point. How do you think the project developers manage their assets in, let's say, the previous era of off-grid projects?
Thank you. Anayo was giving me good insight, and I had the same feeling, like, it's reminding how it was before, And Asantys is an EPC, so we're serving to the project developers, and we could always feel they're struggling how to develop a project, because finance was a big issue. Right. And that's what my first impression, thought was, you see, you can show your business case, you can improve your business case, and maybe even get down the subvention part. You need to finance the system, or make it more reliable finance, and give some security to the investors. And I was remembering, like, when I started, like 18 years back, 20 years back, it was almost unfeasible to develop a mini grid. I mean, the first mini grid I did was 2008 with the help of GIZ. and the German government in Senegal. Yeah. So this was mainly completely donor funded, 100%, just to give an example. Yeah. And to develop that business case was not possible because you have no idea how to refinance it. And now you can prove what you have in the place, and you make a finance case that is feasible. Yeah, I can feel it. Not mini grids are still difficult because we have lots of off-takers. So it's an let's say public infrastructure that has to be financed, and it cannot be left maybe to only private persons. Yeah, so the mixed finance is there, but you can prove what you do to get funding. Yeah. And secondly, I see a lot of requests in C&I projects, yeah, and I see especially a lot of requests from financiers. So I have even more people that are now ready to finance and to bring in money into projects. Yeah, so just please contact us. Then projects in the field are already developed. Yeah, I can see like due to thanks to remote monitoring, yeah, there is. Developers believe we can prove what is happening in the system. In the worst case, we can switch it off. Yeah, and therefore, finance possibilities are coming up without knowing what is happening. It was not happening. It was like Anayo said. Yeah, you get somehow some good willing donors that are doing a hospital somewhere. It was a tough market, and now we are scaling up that quickly. That's why we meet all here together and say, okay, we're in a movement now, and now. What has happened, what is the state of the art, and what's next. Yeah? And we as an EPC, we are following the developers, but I can see like that finance is there, and now it's the question who gets the best solution. There we have this need for sophisticated systems, and that's why we are here. Yeah?
That's why we are here indeed. Sophisticated system is the need of today, and with the advancement of the technologies, the more sophistication is what we are aiming for, and the more, let's say, user-friendly, the more integrated the systems are, we can have all the data that we need in one platform. Then that will bring more success to the project, that will bring more confidence to the investors, that will bring power to the people where they need it, right at their doorstep and where they need. Looking at the time, we have 14 minutes left, and I have one question, which is also one of the questions from the audience. I will circle back to Vivian again. So Vivian, the question is, how do we use remote management today? Is it only for operational monitoring or also for control? Is it for KPI tracking or for external reporting, or what is the basic objective of using remote management? Mind you, it's not monitoring, rather management. The focus of this question is.
So I think there's two aspects there. We use it today to an extent, as Nicolas has mentioned, and I won't go into this question of batteries, managing ambient temperature around batteries. That's pretty critical. I think with mini grids today, we're obviously reliant heavily on concessional capital that invariably is coming from development finance institutions, and is always tied to a bucket load of reporting. And I think that from a point of view of investor management, being able to use data to extract reports, snapshots in time that are formatted and can be easily sent to an investor are pretty important, particularly as your portfolio grows and you find yourself with more and more sites and customers and different types of customers, or even different types of investors who are interested, on one end on marginalized customers, another investor is investing in productive use of energy and want to be able to track that. So I think that's pretty critical. I think we are, some of the examples that Nicolas mentioned, I think are maybe a little, in the classic mini grid operator space, a little advanced, particularly looking at, in fact, I think Anayo spoke to this as well, this notion of having excess power and then being able to market it dynamically. Initially in terms of getting new customers, and potentially maybe going forward even better, and certainly something that we aspire to is being able to introduce a kind of a split tiered tariff system, whereby you can offer customers incentives through reduced tariff when excess energy is available to consume it, so that ultimately they use their credit on their prepaid meters faster, and as a result buy more. I think that's kind of the classic example. And absolutely makes sense within the context of the mini grid model, because at the end of the day, we're chasing for increasing revenue per customer, while at the same time reducing costs of serving that customer on an annual basis.
Thank you. Maybe a quick follow-up question: is the remote management is well understood and well received by the end user? Are they happy with all those sensors being put and installed in their houses or in their basement?
Well, so today we do not do appliance monitoring. We do point of service monitoring. So we have meters that measure energy and power and that kind of thing, and then we have the generation side. So the customer doesn't really see it. What is interesting is being able to market that customer by SMS and say, hey, anything that you consume over the next 2 hours will cost you 50% of the price, which basically, invariably translates into the customer being a little less careful about running the fan, or not worrying too much about the fact that the TV is on for more hours than they normally budget for. So I think that's kind of the classic example in terms of making business decisions based on the availability of data. And then, of course, the other classic example was mentioned already, which I won't go into, is diesel generator, right? Is being able to track over time what a demand profile looks like on a given period of time, and not automatically switching on the genset just because the battery is at 30%, but being able to say, hey, I'm not likely to deplete the battery more than 5% based on current demand and what history tells me about demand. And so I can delay turning on the genset and only really turn it on if the battery gets down to 25 or 23, which then at the end of the day has direct impact on that notion of OPEX per customer.
Right, indeed. Then moving on to Claudio. Claudio, how do we use remote management today let's say in your experience and in your company? Is it only for operational monitoring or also for control, KPI tracking, external reporting, as Vivian was also mentioning, and so on?
Yeah, I think Vivian already mentioned the most important use and application from this point of view. But from an operational point of view, that's equally important, because basically remote monitoring and management means literally that thanks to the information that you acquire, that you can receive on your desk, you can remotely activate some action that are on site, thousands of kilometers away. So some example are some also connecting to what Anayo mentioned before, some technical intervention, right? If you see that there is an issue on I don't know, on a containerized solution in Nigeria, temperature is going very high, the battery are low in charge, there is no sun for some reason, then what you do, you turn on the diesel generator, you force it to turn on remotely, then you switch on perhaps simply your AC to the maximum if that is working. And that is something that you do thanks to the data that you have acquired. That is management. Also, you can, for example, like in this case, but even without a technical issue, you can decide based on the data that you acquire, which are priority load that you want to serve before than others, right? If you see there is little to no power available either in the storage system or in the generation side, and I don't know, the diesel generator does not work well or is not enough, then you decide where to send the power with your computer, right? With your remote monitoring and control system. So you choose an hospital and you shut off a private consumer, perhaps. That's what I see happening in terms of operational.
Maybe being mindful of the time. We have 7 minutes left and 2 speakers to go. I have a quick question. The companies that you are investing in, are you also, let's say, paying attention to what kind of remote management system they have? And are you also asking for all the reports that they generate, that they have to submit as a matter of, or as a part of the contract that you are forging with them as part of investing in their companies? If I made myself clear, yeah.
Definitely, I think not only for myself and us, but nowadays, especially in our sector, the familiarity with data acquisition and digitalization, it's a must. So the expectation of any company, regardless of what technologies they have or what business model they use. Their familiarity with those technologies, data acquisition, IoT, it's a must, Deepak.
Right. Right. Thank you so much, Claudio. Then, Anayo, what's your input to this question of how do we use remote management today? I mean, I have already received more or less than your inputs on how exactly the remote management and what is the future potential of it. However, in your own case basis in Nayo Tropical Technology, I would like to hear more about how do you use the remote management?
Yeah, thank you, Deepak. Actually, I'm here wearing two hats, one as an EPC operator and as a mini-grid utility operator. From two sides, I'm going to answer this question. As an EPC operator, you can advise or prefer a better solution for your clients. When you're designing systems, you draw from experience. You have clear data to show your customers, like we had a situation where we had a design, a shelter design we offered to some clients, and they were insisting of a particular dimension. We had to use data we collected from an operating system to show them the impact of temperature distribution using that particular type of design they wanted. It shows that the systems that were closer to the cooling system were running at a different temperature, while those far away were running at a higher temperature. So it couldn't have been easy to to convince this client, because they had diverse opinion from different EPC contractors also vying for the same job. But when we put out data collected from our operating system showing temperature distribution, and like Nicolas said, this temperature, 1 degree change in temperature can add or drop the life of your battery. So it's very critical. So this is just a practical application on the EPC side. On the O&M side, we're looking at long term, we're looking at O&M costs, we're looking at performance as optimization of these systems, because one, there are things you are in control of. We're looking at also there are things you cannot control when it comes to like the social part of the community. You could control your machines, but you can't control the people. So you could use technology to influence how you want the people to use the system. That will help optimize the system performance over the life cycle. There's a way we tweak systems when they start getting older, the batteries start depleting, and they can't, if you adjust, you can see that you can adjust the DOD from 80% down to somewhere around 60% because they are getting older to get more juice. You can adjust that because you understand you have raw data to work with, and then you could find ways to manage all that without the typical high capex in midlife upgrades and system reconfiguration. So the possibilities are endless. What we could do as an operator. Then again, as the industry is shifting a bit from the typical second generation, build one mini grid, fan it forever, to scaling out to hundreds of mini grid. Right. It becomes so imperative that you have to limit, you have to reduce the cost and also improve on your rollout efficiency, with the commercial efficiency and the O&M efficiency. And at scale, it becomes even a bigger problem to do this at scale. If you looked at Nicolas' presentation earlier on, you could see how a dashboard, a typical dashboard where you could see pop-up of your site. You don't need to be so much a professional to see when a pop-up site turns blue or green to kind of log in to find out what that green or red means. If you wake up in the morning and you see green all over the board, it's a good day for you. And suddenly you see it's very easy to do that. And it's fun to be on that dashboard. But when you're sleeping and the call comes through and somebody shaking, maybe speaking a local dialect, you can't hear, calling you that they're out of light, and it takes you hours or days to even translate what he means, and the efficiency of the entire system. But here, sometimes it's you on the dashboard that calls up someone on site, say, hey, where are you? Go to the site and check sensor A or B for me. Can you switch it a little bit? That's the other way around, because you see this fault. It is more a intervention, a preventive kind of intervention, rather than a fire service intervention. When the system has already gone down, you must have lost equipment, lost revenue, and maybe lost reputation. So you could prevent these three losses by using remote management to see events before they happen. We have trigger points we set. In fact, we had a system we had to shut down. We had 2 air conditioners on a particular site. And when we found out that a new capacity is needed to be deployed, we use remote management to manage our air conditioning system consumption. And the excess energy, we sold it to a new capacity. We use it to develop new capacity. So we now developed our system into a slave and master air conditioner setup. And at that place, the excess energy we saved from the air conditioner, we sold it to someone else. You could have done this before now. It takes a lot of IoT experience, and also trying to align it to the real life scenario on ground. You could play around these opportunities and get the best out of your mini grid projects.
Right.
So there's a whole lot of possibilities. It's endless, but you just need to, the technology is ripe, is there. The market is ripe. The people want energy, and now the investment is coming in. That's where everything comes together. And I think we could scale with the current remote management capability. The technology is getting better by the day. The internet penetration is going for, you heard what William said about in the past 10 years. Today's technology, 50% of our sites run on dedicated VSATs at less than $300 for initial setup and less than $30 per month subscription. So you're more than 10 times that 5 years ago or more. So you can see the technology, the cost of deploying these technologies are going down. And so that can enhance penetration of remote monitoring technologies. So I think we're at the right junction right now. The scaling and the technology is like, at a good convergence at the moment.
Yeah, we're at the right junction indeed. The technology is there. This market is ripe. All we need to do is just hit the right keys and get going with the integration of these technologies, including the human behavior that you mentioned, the way we operate and manage, because it's very funny when you mentioned that we can control a machine but not a human, which is by every means right. So let me also take the input from Nicolas on this very point of remote management, and then we will end the panel discussion and go over to the audience Q&A. Nicolas, the floor is all yours.
Yes, thank you. I mean, I have not too much to add, but many things have been said now, and also the time is over. I think for us as an EPC, it is even helping to consult our clients for new solutions. I just came in my mind, we have installed a real estate somewhere in West Africa, and the system is growing, or let's say the system is growing, but the loads are growing, yeah. And in the end, sometimes customers that don't really understand solar say, hey, I need a bigger system, just add panels, yeah. And then we have the opportunity to have a precise look on the loads and on the behavior of the system, and see, no, but you have a lot of excess energy that was not stored because your battery was, let's say, initially too small, because we didn't know about the loads development, or we didn't know. Often you have the case, you don't know what will happen in the system, yeah. Your sales are based on a load estimation, but reality is different, yeah. And it is helping us a lot, let's say, to customize extensions of the systems and say, hey, no, you don't need extra panels, you need X amount of battery, and then your systems will be perfectly running, and you use 100% of the energy you're producing already, or vice versa, yeah. But this was just the current case that I had, and I think I don't know, are we handing over to the question and answers, because I got already questions that I can start answering, but I would hand it over to you and moderate it, yeah.
Yeah, well, let's
Going
do
back
it
to
that
the
way.
EPC question, and therefore it's a mix now. Yeah, but
okay,
please.
well, let me come back to you right away, though. Thanks a lot, dear panelists, for your insightful intervention. I think this was really interactive, really insightful, and very informative for our audience today, including myself, because I got to learn a lot from you. And well, with this just keeps motivating me more and more to learn about how remote management and integration of modern forms of technology can help scale up more and more mini-grids and then lead to the access to energy by the global population. That is basically the whole agenda is all about. Then without spending more time, let me circle back to Nicolas, and I will let you answer the question that you wanted to, please.
Excuse me. The question was if we can give more details about what kind of variables could be monitored during the deployment phase of the project. Yeah, this is a pure EPC question now. Yeah, and I was telling about what we discovered with the spider and what the battery sensor on. But generally, it is a very good tool to assist our installers in the field. That's the first topic. Yeah, I mean, I traveled a lot in that project. Yeah, and you're working under very hard conditions. Yeah, I mean, imagine it's 45 degrees, sun is shining. Yeah, you're inside and then the container, and maybe 60 degrees, and you're under much stress installing a system. Yeah, and sometimes the conditions are that harsh that it's good to have a third person or an external person outside. Yeah, and we have our team over here sitting in Germany, being able to assist to the installers. Yeah, and have a clear head, clear mind. Yeah, sitting on a desk and seeing what is happening in the system. Yeah, and then you can give good advices like. Hey, I mean, why have we not detected this inverter? And say, yeah, did you think of setting the plug there and so on? Yeah, because sometimes it is not feasible, and so it is very helpful during installations. Yeah, to complete an installation on time. Yeah, if you have the possibility of assistance from remote. Yeah, imagine also an inverter. Yeah. You have an interface to an inverter, but one inverter. Each inverter has one, yeah. But it's good to have a complete view of the system, yeah. And then you can advise the installers in place if they don't find it by themselves how to do it, yeah. And when we are commissioning a system now and assisting remotely, we can test everything which is on the site. So we can. I had the Minister of Energy in one container, and he said, "Yeah, what do you want to see now?" Well, we switch off the fan, we switch off the AC, yeah, we switch on light. You see, we are sitting in Germany. Hello, yeah, and we control completely the system, and that's how we do the tests. Yeah, we have a performance test of the system before it goes on. Let's say to be connected to the customers, so we can test every single relay. We can check if the system setup is done correctly. We have real-time load tests ongoing, and a complete overview about all controls in the system. So that's all done in a kind of part of assistant remotely. That was one of the questions I received in the beginning, and it was just combining what we've been discussing already in the panel right now. This is what we do as an EPC during the work with remote. You know?
That's right. There is a myriad of options that we have. That not only the system itself, but there are other in extrinsic factors that can also be monitored with the integration of remote management system. Thanks, Nicolas.
And sometimes it's fun just doing jokes, yeah. Because if I have my camera on and the loudspeaker, I'm saying hello to the village, yeah. And also fun needs to be part of the work, yeah.
I'm sure the people in the village are saying hello back to you.
Yeah, they did. Yeah, that's crazy.
Okay, moving on to some of the open questions from the audience. I think this is a very interesting question, and I will take answers from all of you like I did during the panel discussion. What do the panelists see as the most likely additional benefits of having access to the data beyond operations and monitoring? For example, it could be carbon credit trading or crowdfunding, etc. Let me just follow the same order as we had. Vivian, you wanted to also answer this question. So please.
Yeah, I think actually I have already. You know, this notion of reporting for concessional capital purposes is, you know, for us certainly with 5,000 customers, it's becoming a significant manual load, and being able to pull reports from real data, you know, adding an executive summary and having everything formatted like that, so you can, you know, tick that box and get that report out the door to get the next payment or whatever it is, I think is really, really important, and definitely useful. And then early on, I had covered the other aspect of the question, so I think I've covered that.
Yeah, thanks. I indeed second that statement, because the more time we spend on project development rather than the report writing, the better it is for the whole system, the whole project itself. So I would definitely agree with your point. Claudio, what do you think on this point? I'm sorry,
Deepak, if I can.
Please,
sorry, I just wanted to add one more thing. There was something there about carbon credit financing, right? So obviously that's the trend now, with the latest COP that supposedly is the future of finance. I think that more and more we'll start to see renewable energy credit type financing stepping into the space as the sector grows. And, you know, at the end of the day, every kilowatt hour that you deliver is money in the bank. And so being able to track that in a real-time format that is transparent and complies with international governance will be critical to be able to secure that kind of funding going forward.
That's correct. Yeah, that's indeed a very valid point. And every amount of every kilowatt hour that we have is the money, and that's why definitely that shouldn't go waste. Claudio, coming to you on this point of additional benefits of having access to data, I see that you're a great advocate of data acquisition and management. So I would also like to see what your thoughts would be.
I think it can definitely be useful from a finance perspective, especially in the future. Talking about carbon credits, which it will become more and more important. And the big innovation is that we will see more and more opportunity in the unregulated market of the carbon credit, which is everything that applies to the mini grid space. So the ability and the possibility to demonstrate in the most reliable and accurate way to demonstrate what are the kilowatt hour and consequently the CO2 reduction that one project is delivering, it's going to be critical. And it is equally critical already for the investor, for the impact investor. Those ones that are able to demonstrate the technologies and setup and the know-how that they already have to monitoring whatever they are doing in Africa, how many kilowatt hour they are delivering, in which way, what is the impact that they are delivering, what are they doing with the kilowatt hour? Are they allowing the distribution of clean water? Is that measurable? If that is the case, then they have a big advantage, and the impact investor and whoever is managing concessional finance will be very pleased to see those capabilities, right? Because this means that they can, from their desk, access at least partially to those information that leads to real impact at the end. So it's becoming more and more important in this sense as well.
Indeed, impact measurement. There is also a question from the audience. I think, Claudio, you're well placed to take that right now. Is there any type of data that you would like to have, but is not accessible or measurable yet?
Well, in theory, you can already measure any physical data, right? The point is how you translate data acquired into usable information. So if you want to describe what is the impact of your project, how many people you are serving, or I don't know, how all the indirect advantage of the arrival of electricity, then you need somehow to build some logic on the interpretation of those data. Yeah. And if you are able to do so, you have already to implement it into the data, into the technology that you have. So if, for example, to make it simple, something very easy is to translate the kilowatt hour that you generate into CO2 reduction. That is an algorithm implemented there, but it's an interpretation of the actual energy produced from the solar panel. And the more you can do that with other different aspects of what is defined as impact, the more you can. So to make it short, it's very easy already to acquire any kind of physical data from the sites. It's still a little bit a challenge, but not possible to interpret the data and translate them into impact that those projects are delivering. I'm sure also Vivian has an opinion on this topic as well.
Yeah, I can step in very briefly. So one of the challenges we've always had as a social entrepreneur, social enterprise is taking kind of baseline studies on Human Development Index and being able to show over time that family, that customer's life has changed. And the obvious example within the context of data is that if you have a customer who traditionally used kerosene for lighting and did or didn't have a mobile phone and would charge it wherever else, the theory behind all of the fundamental mini-grid business is the cost of kerosene for lighting is $4 or $5 a kilowatt hour effectively, and the cost of using batteries, torchlight batteries, is somewhere around $1.70 or something like that. And if they're paying 50 cents, then it's less, so they must save money. But it's difficult to demonstrate that. But when you have customers that suddenly can afford a small radio, potentially a small television or a fridge, and you can demonstrate what they're spending their money on an ongoing basis, and suddenly a customer that was regarded previously as base of the pyramid, less than $2 a month per person, who now per day per person, sorry, who now suddenly is spending $5 or $10 a month on electricity, and they've been able to finance a fridge. That speaks to economic development. And when you talk about KPIs and impact data measurement, having data available that demonstrates that, whether you finance appliances yourself or not, or whether you understand what appliances they've been able to finance, that speaks a lot in terms of economic development. And I think that's an example of KPI reporting that is pretty critical and wouldn't be able to be done possibly, without access to the data.
Right. And I would also add it here that we can pretty much measure anything and everything as long as we put right indicators. And in this case, the indicators, as Vivian was mentioning, are let's say the gadgets that were brought to a house after they had access to electricity, so that we could now measure the economic development of that particular house. And when we extrapolate that region, that village, that region, or and basically the whole area. So I think that's a very valid point. I would go back to Anayo with the question of what are the additional benefits of having access to data beyond operations and monitoring.
Yeah, thank you. I think project.
I'm sorry, Nayo, are you with us still? I think we have a connection. Yeah, I think we lost him. Speaking of losing him for the time being, let me go to Nicolas. There he is.
Sorry, I lost connection. So the use of data is endless. For now, for the mini-grid space, there is a whole lot for fundraising, for future system design and optimization, because there are 3 stages in mini-grid development: project development, construction stage, operations, and optimization. And optimization is when you compare assumptions to reality on ground. What do you do with this? What is in between is the actual clean data you could work with. Then you have to either use it to scale the system. You could also use it to bring in new partnerships, like into the community to improve livelihoods, sustainability, and overall performance of the system. Right. The mini-grid ecosystem is not just deploying and giving power. Now there is power. What do you do with it? It's something you have to sustain so that there won't be payment fatigue. They won't develop payment fatigue after a period of time. So you just have to, you are still responsible in keeping this, continuing this social engineering to keep this party going on so that they will have this more activity, more money, more disposable income to pay this premium tariff for a very long time for you to recover your investment, keep your investors happy, keep the community happy. And to do that, you really need precise data out of the operations to keep managing this relationship for, an ongoing basis, and having also the capability to project into the future, the capability to use this to bring in new partnerships. Let's say you have 10 mini grids in a cluster, you could look at your data from collected, you could, put up a business development strategy around EV, adding EV to your portfolio, or adding bringing in internet services. So there is a whole lot of capability that you can explore if you have quality data from your operations. So we could go on and on.
Yeah, that's correct. I mean, it's not always about the operation or monitoring of it, but there are different stages of projects that everyone can focus on, and the data is always what we need in order to do it in an effective way. And what you mentioned is definitely has a lot of strength, to the point that it's not about only having the data, but rather the precision and the quality of it again. So thanks for that. Nicolas, your inputs on this point, please.
Yeah, I think most of the things have been said, and I'm always in the last of the round, but I think it was starting also if carbon credits could be used, for example, or crowdfunding, and we've been involved in several projects where it has happened already. I don't want to name it, but let's say our partners, as we an implementer and EPC, used carbon credits as they could prove how much diesel they saved, and was a significant part of the finance that was making that project happen. It was a really big microgrid project. So I think it is already reality, and it's a question of mixing it up, but it was giving definitely security to the carbon credit fund, that we could deliver data and reliable things after investing.
Yeah, thank you, Nicolas, for your answer. Then let's, being mindful of the time, let's have last, let's say, 1 minute closing remarks from all the panelists to kind of close this insightful discussion that we have. And we will follow the same order, starting with Vivian. Vivian, a very quick closing remarks from your side based on the discussion that we had today.
Sure. I think we provided solid justification for why remote monitoring, and particularly management or business-based decisions based on data, is critical. We haven't covered one really important thing, and that is cost. We as developers, operators, are always under pressure to drive down capex per customer. It's a very critical kind of initial metric that investors look at. Within the sector, prices on the continent range somewhere between $500 and let's say $900 per customer, depending on country and taxes and all that kind of thing. In our experience, looking at standardized technology, such as what Odyssey and Fintech offer, account for typically less than 2.5% of that capex per customer. So to put that in context, you're talking about less than $20 per customer as a capex investment. And I don't know about you guys, but I don't know about a business where you can put a technician into a rural community in the middle of nowhere and charge them $20 a year, and they're actually going to accept that service. So it's highly cost effective, and even if you don't use that technology to drive your business decisions, just the peace of mind, and I'm sure Nicolas will speak to this, just the peace of mind to know that you have all these systems out there and that they're working and there's no issues, is immense. And that $20 per customer is absolutely worth it. So if you know, for all of the developer operators on this thing, if you're looking at scaling up, figure out where else you can cut costs on poles, cable, whatever the case may be, but don't cut costs on remote monitoring. Thank you.
Indeed, that's a very important point. Vivian, I think this could be an idea for a follow-up webinar that I would suggest Team Odyssey to come up with, that the cost of remote management, that is a very, let's say, essential topic to have a discussion around, and the audience would be very much interested to know more about it, including myself in there. Claudio, your last remarks, please. Please, and in 30 seconds.
Yeah, also building on what Vivian says, I would highlight the cost of not having remote monitoring, because that is the topic, right? It's not sleeping in the night, knowing that your stuff is out there in the middle of nowhere. It's if something happened, really disaster can happen. And but I'm very glad that remote monitoring is becoming really popular. Most of the technology manufacturers are now integrating their own monitoring system and platform as well. What I'm expecting to see in the near future is the next level. So data interpretation, so algorithms and automation that is automatically interpreting most of those data, and this will actually not only give peace of mind, but this will bring actually OPEX cost down of any solar and storage asset, for example.
Yeah, peace of mind again is the key word that we are following in the last remarks. Speaking of which, I would go to Mr. Anayo. Anayo, 30 seconds, please, your last remarks.
Thank you. I think the next frontier in remote monitoring and management, like the word said, management is different from monitoring, is effective automation. You know, bringing, you know, trying to send commands from a remote and not just, you know, so that you can intervene. We here locally have started with our, you know, friends around the world. We're working on projects, several projects with, you know, research institutions and business with like minds like Odyssey and Fintech. We've been on this project for a while. So expect to hear more. Also, we are open to collaborations on automations, you know, remote monitoring and automations. That's the next way to make use of this data real time and improve the industry. Thank you.
Thank you. Thank you so much, Anayo. Nicolas, last words, please.
Like in the beginning, everything is said. We would like to thank Odyssey for taking part of it. I took two key sentences with me. For myself, I was saying in one of the questions, like that remote monitoring is a game changer in off-grid business. Yeah. And we can be thankful that we have data available to make it happen, that we can give access to energy in rural areas. Yeah, that's the most important, and the most important advantage that I see is we can see what is happening. Yeah, and this is fantastic, and I'm just grateful having a trustful partner on our side.
Thank you, Nicolas. Thank you, everyone. Dear panelists, that has been an absolute wonderful discussion that we could expect today. I'm pretty sure that the audience and the team and everyone out there listening into our discussion today have been very much well informed about the topic and have taken very good key lessons learned that they came here for. With this, I would also like to conclude my remarks just to reiterate the point that ARE, being the oldest and the biggest association in the DRE market, is right there to support the private sector to help realize the off-grid goals that we have together, the common goal of the global electrification. If you have questions about that, please get in touch with me. And with that, I would like to hand over to Mr. Patrick Cousins. And this has been a wonderful experience. Thank you so much. Thank you, everyone. Patrick, over to you.
Thank you, Deepak.
Thank you.
Yeah. Thank you. Thank you, Deepak, for keeping such an experienced panel entertained and under control. I must say it's been really a lot of fun listening to all your inputs and comments. So thanks to Nayo, Vivian, Claudio, and Nicolas for that. I realize I'm running out of time, so I'll try to be pretty quick. I'd also like to say it was great that we got 250 registrations for this event. A lot of people want to watch it afterwards when they're not out on the site or somewhere doing work. So yes, that will be available. Yeah, that's good news there. Just to circle back on some of the things summarized really quickly. I believe, of course, there's a lot of things to unpack here, and we won't be able to finish it all, but we've started a few things. People are really interested in, of course, remote diagnostics, optimization, which improves efficiency, which improves profitability, which improves investment possibilities. So it's a kind of a circle here that we're following up on. And of course, then can reduce risks, which allows greater access to investment. So it's this seems to be a major topic amongst everyone here. We also, I'd like to say that we've all talked about mini-grids today, but this does apply equally to commercial and industrial projects in many scenarios. I think Nicolas mentioned it, can't exactly remember, but there's a lot of interest now in this area because solar energy, decentralized power is now the cheapest form of energy if you do it right. And yes, we should have another webinar, maybe talking about costs, pushing down the costs and how that can be done, because it's becoming now the imperative. It's the way to do it rather than an edge case. And that's great to see. To everyone listening, you will receive a request for feedback. Maybe you enjoyed it. Maybe there's things we could have improved. Please do tell us. And also do tell us which subjects in the future we should bring up in future webinars, because yeah, this is a good format. I'd love to meet you all in person, but at the current circumstances, that's not yet possible. So we'll rely on this format. So I've kept it really short, nearly on time. Thank you very much once again to everyone, and also to all the listeners. And we will keep you informed as to when the next webinar occurs and about the subjects we will cover. So thank you very much, and all of you have a good evening or morning or night as it occurs. Thank you and goodbye.
Thanks a lot, Patrick. Bye-bye, folks. Thanks a lot. All right, bye-bye.
Bye. Bye-bye, everyone.
Bye-bye. Thank you.
Thank you. So, I believe it's off. Great.